I mean, this is the most important. This is my little bonus vent. I'm going to rant about this for a second. Refrigerants should have never been three-character series for blends. 400 was not enough. We needed 4,000 from the beginning. There's the end of my mini rant. But I'm excited to talk about the actual transition itself. I think there's a lot of misconceptions about what A2Ls mean, these new mildly flammable refrigerants, and understanding that this transition is really more similar to what we've seen in the past and milder than what we've seen in the past. And I think people maybe give it credit for.
Welcome back to Let's Vent Podcast. Today we had on Nick Harbeck with Johnson Controls. We met on the showroom floor of AHR, and Johnson Controls invited me out to be a part of their booth. And as the entire event was opening, people started rushing into the showroom floor. I got to sit there with Nick and have a great conversation around the changes that are coming to the industry in terms of A2Ls. Obviously, now it's been a full year of these being introduced. So we've kind of seen how this has played out, but it's interesting to look back on this a year later and see what some of those predictions were and how some of them came true and some of them didn't. I think you're going to find it to be an interesting conversation. So enjoy this chat with Nick.
Well, welcome to AHR. We are live on the very first day. It just opened. People are pouring in. We're having a blast here. Looking forward to 3 days of chaos. Absolute chaos. Organized chaos. You guys have a fantastic location here. We're here with Nick Harbeck using Johnson Controls, and we're going to be talking all about A2Ls and what it is that we can expect from it. But before we get into that, why don't you tell us your story? How'd you get into the trades? How'd you get started with Johnson? Yeah, awesome. Thank you so much, Evan. Good to meet you. Glad to be here at AHR Expo. Like I said, my name is Nick Harbeck. I am a part of the regulatory and sustainability team here at Johnson Controls. Been in the industry for almost a decade now. Got into it as a chemist. Really was interested in getting into environmental policy and figuring out ways to regulate emissions and look at how governments actually perform that. Ended up working for AHRI, the Air Conditioning Heating Refrigeration Institute, for a few years. Again, focused on that environmental policy aspect, and then moved over to JCI a few years ago and been loving it. There's a lot of really cool stuff that this company's been doing, and really the industry as a whole has been stepping up the game in terms of what it looks like to transition to new refrigerants, put out new products that are highly efficient, and just generally making sure that people are comfortable in their homes, right? Ended up kind of focusing more on the policy side as we got further and further into the career, and now excited to talk about the refrigerant transition today. So thanks again for having me. Looking forward to all this.
No worries. Thank you for taking the time. I appreciate that. Well, let's just dive right in. And the theme of the podcast, let's vent, right? Let's get off our chest the thing that a lot of people are avoiding talking about. So absolutely, I'm going to give you the floor. Get up on your soapbox. And what is it that's on your mind? What is it you're discussing?
I mean, this is the most important. This is my little bonus vent. I'm going to rant about this for a second. Refrigerants should have never been three-character series for blends. 400 was not enough. We needed 4,000 from the beginning. There's the end of my mini rant. But I'm excited to talk about the actual transition itself. I think there's a lot of misconceptions about what A2Ls mean, these new mildly flammable refrigerants, and understanding that this transition is really more similar to what we've seen in the past and milder than what we've seen in the past. And I think people maybe give it credit for.
So why is everyone getting in their head? Why are they getting bunched up about it? Their panties in a bunch when it comes to this.
No, you raise a great point. It is a good reason to get concerned, right? This new transition is now looking at how we are dealing with flammable refrigerants. I think when people think of flammability, there's this misconception and this misnomer that if it's flammable, it's going to explode, right? And that's not necessarily true. I mean, when we think about things that are flammable, we have non-flammable items. I think folks have been familiar with 410A as just a refrigerant example, where you can try to burn it and not going to get very far. But when people think flammability, I think they think propane, hydrocarbons, and all of these other aspects of the flammability spectrum that are things that go boo. And that's not necessarily the case either, right? Like when we think of things that burn, you can have like a log, and a log will burn and it'll propagate a flame. That's different than actually putting out like the Boy Scout lighter fluid method and try to get a flame going really fast. And the same thing happens with refrigerants. When we're talking about things like 454B and R32, and even some of these new HFO blends that are technically considered flammable, the actual flame associated with that is pretty minimal. But I think people generally think at first glance, first blush, oh no, this is going to explode if I ignite a flame. I mean, what we found in the data is that these new refrigerants are mildly flammable, which means they propagate a flame at less than 10 centimeters per second in terms of burning velocity. That's a really nerdy way to describe me trying to light plastic on fire. I can do it. I have to have a lighter, and I have to be constantly applying that high energy ignition source onto the refrigerant. If I take it away, flame goes away, there's no actual ignition. So a lot of it is making sure that we change the way that we maybe install products or work with products, as well as design products so that it can be performed safe. One of the things that I found kind of interesting is that the way that these new standards have unfolded and the way that product has changed and the refrigerant safety considerations have unfolded in is that we're attempting to make the flame events, the ignition possibility practically and physically, and I mean this literally, the hospital, right? I think you're probably familiar with this and most folks will be as well. There's a certain concentration of refrigerant to oxygen that we have to have flame. It's the three-legged stool. You got to have fuel, you got to have oxygen, you got to have heat radiation. And the band in terms of flammability for these A2Ls, 454B and R32 especially, is so narrow that if you don't have that perfect mix of oxygen to refrigerant, you're not going to have anything happen. So a lot of the engineering design work that's gone into place, a lot of the standards and the regulations that have been put into effect are to make sure that we never get within that band so it stays impossible to ignite. And I think making sure that we emphasize that portion and making sure homeowners are also comfortable is really important as we are now in the transition in 2025, and we'll really see it borne out in 2026. But it's a great question, and there's a lot that goes into our.
Got it. No, that makes a lot of sense. And we'll get into the homeowner conversation in a minute, but I think more importantly, I mean, for us, our audience is a lot of contractors, right? It's the owners themselves. How do they communicate this to their technicians in a way that allows their technicians to feel good about it?
Right. That's a great question. I mean, when you think about refrigerant transitions, this is a little bit different than what we've seen in the past. So there's maybe some consternation or concern. Whereas, R22, the transition from these chlorofluorocarbon, the hydrochlorofluorocarbons, too many syllables, was maybe a little bit easier to digest because there was this option for drop-in replacements. There are these similarities between refrigerants that allowed you to take a piece of equipment and say, hey, this is going to operate the exact same way. I'm going to charge in the same manner. I'm going to service in the same manner. I'm going to be working with the refrigerant in the same manner. You had some changes in working fluids and oils that were compatible with these new refrigerants, and you have different glides. But the transition itself in terms of working with refrigerants is similar. What's maybe different here with A2Ls is that the actual process for working with refrigerants is a little bit different, right? We have new installation requirements. And so to get back to your question, making sure that people feel comfortable with that is just making sure that we understand why some of these changes are occurring, and then simplifying those downsides. I think people get a little bit concerned about, flammability. But just like with R22 to 410A, 410A to 454B, or 410A to R32 is essentially the same kind of story. There's slight modifications to what you do around the edges, but the vast majority of the actual day-to-day operation of refrigerant is exactly the same. Right? Still got a little bit of glide. It's still operating at high pressures. You still got to make sure that system's sealed up. You purge it with nitrogen, hold that vacuum all the way down. That's the same to 410A. So there's really no difference there. And just making sure that you communicate that aspect of it from a technician perspective is probably the first step. And the second step is making sure that homeowners feel comfortable with using this refrigerant that's entering a space, but is designed to be charged in a way that it's not going to cause harm to them. There's mitigation measures put in place to make sure that they don't have to worry about what happens if there is a leak. And those are kind of the big steps that are happening from an engineering front. Hopefully take some of the weight off technicians, right? If you want to go into a home and say, hey, don't worry about this, homeowner's going to ask why. And if you can go back and say, hey, we've redesigned the building codes to make sure that this refrigerant is safe. You've redesigned the product. We now have a refrigerant detection system on every unit in America, with a few exceptions, which you maybe talked about, that allow you to get this product installed safely and this refrigerant use, you can still be comfortable.
Right. Well, and I think one of the aspects that's often missed when having this conversation is the fact that the product is slightly more dangerous, right? Means homeowners are less likely to touch it. So now there's more work for contractors, there's more work for technicians than there was before because there's more concerns around it. Yes, right? And so it actually is a good thing as long as the training's in place, as long as you're taking care of your people. Put the time in. Does Johnson put on trainings for?
We do. Yes. I think not even just to promote Johnson Controls, but I think really everybody's working together on this. This is an industry-wide effort. And there's trainings out the wazoo, right? We have organizations like NAPE that are putting on new AHL training. We work closely with the ASTO Institute. They put out some great resources. Internally within Johnson Controls, some of our partners, we're working on trainings to make sure that this potentially scary transition isn't as scary. And again, like I mentioned before, the actual changes in terms of training are still very minimal.
Right.
So
marketing isn't magic. It's math. At Free Agency, we've got the formula tattooed on our brains. We are not a digital marketing agency. We don't just throw things at the wall hoping they stick and call it strategy. We're a fractional CMO. The people who come in, grab the wheel, and drive your growth like it owes us money. Our system isn't guesswork. It's battle tested at the highest level. Last year, our clients averaged 45% growth. We've taken companies from 8 figures to 9 in just 12 months. And here's the kicker. We don't do it by blowing your budget. We do it by spending smarter and focusing on 4 core moves. 1, branding, to drive your brand in your market. Two, paid leads. We bring in high intent leads into the business, customers who are ready to buy. Conversion, focusing on turning those leads into clients. And lastly, nurturing, to increase the lifetime value of every single client. Every step is intentional. Every dollar is tracked. And if you're spending $1 million a year in marketing without a 10x return, yeah, you're flushing money down the drain. We work with ambitious, no BS contractors who don't just want to try marketing. They want to win. So if you're ready for 50 to 100% growth in the next 12 months, let's talk. At Free Agency, we don't just play the game. We rewrite the rules so that you win every time.
So now a very important topic. Yeah. Arguably the most important when it comes to business. Oh yeah. And profitability is how do we communicate this to consumers, right? Being able to take all of that industry jargon, right? Words that are very complicated and complex, and distill it down in a way that a homeowner can understand what it is that they're putting in their home. How do we get technicians to get on that level to be able to properly communicate it? Because I really do see them as translators when it comes to understanding how to heat and cool a home. And so what is your process? What is it? How would you break that down for a technician to be able to explain that? No, I love the way you put that. As a translator, the technician really has a great opportunity to speak to the homeowner in their own language. And I think when I think of the homeowner, I mean, probably in the same spot as you and I'm worried about cost. I'm worried about reliability. I'm worried about performance. I'm not necessarily worried about the specific chemical composition of what's in my air conditioner. Right. And I think as a technician, you have a great opportunity to frame this as a cost-saving measure, a future-proofing measure, a way to make sure that you can stay comfortable for the foreseeable future. Here in the U.S., we have this umbrella of regulations under something called the American Innovation Manufacturing Act. It guides the transition down of refrigerants as we move away from these higher global warming potential products to newer products. We have the actual technology transition itself, which is affecting what products can use what refrigerant. And then we have the refrigerant management aspect. And if I'm a technician, I think there's a really great sales pitch here for being able to go to a homeowner and say, hey, there are these government regulations that are out there. We have this step down in what's allowed in terms of refrigerants, but I'm going to be able to provide you with a 454B or an R32 unit that's able to stay in your home, and you're going to have adequate supply of that refrigerant for the foreseeable future. I think one of the things we've seen, R22 is a great example. Once the transition out of the old refrigerant occurred, we saw huge spikes in price and scarcity of this refrigerant. It was hard for technicians to get it. It still exists out there today, but it's harder to do. Right. And so if I can go to a homeowner and say, hey, you're going to have this piece of equipment for 10, 50, 20 years, hopefully not more than that, but they're going to have it for a long, long time. And they want to make sure that they have that longevity. And this new refrigerant is going to have that longevity. We're going to see 410A diminish in supply over the years as the Environmental Protection Agency continues to restrict it. And I think as a technician, you can go in and say, hey, we're going to make sure that when you have a problem in 10 years from now, because all mechanical things have issues at some point, I'm going to be able to service that need. I'm going to be able to do it in a cost-effective way compared to maybe sticking around with some of these legacy products that might not be able to have that. Even though they'll still be available to be serviced, the more we transition or collect it as an industry, the less cost there is for the end user. Right. Well, and that's a huge thing, right? And making sure that customers understand the cost savings over time. It's not an immediate savings, right? There is going to be an increase, especially with the other things that are happening in the regulatory space. And the government level right now is T word that's being imposed on Canada specifically. We're getting scared. But no, when it comes to things like that are outside of your control, what can you bring back into your control? And then how can you communicate that effectively and bring it back down into their level? I think that's huge. I love the cost savings aspect of it. How deep would you recommend a technician go into the environmental savings and the impact there? That's a good question. I think the environmental component a little bit depends on who you're talking to. Some folks just are going to care more about the cost and reliability and the impact on their bottom line in terms of the electric bills, right? And there's definitely a sustainability and environmental component to all of that. And weaving that in, I think, is the opportunity for the technician to vamp a little, right? There's going to be that opportunity to go to that homeowner and say, what matters to you? I want to learn from you, homeowner. What do you want to see in this product that you're getting out there? And some people are going to be interested. You're going to have folks that are going to say, hey, I've heard about this transition. What's going on here? Can you tell me more about this? And that may be a good opportunity to say, hey, not only is this going to future-proof you, it's going to save you money in the future, you're also contributing to helping the environment out by not releasing or potentially releasing refrigerants that could affect what's going on in the atmosphere. It's that dual story of being able to be efficient with these new refrigerants, because frankly, these new working fluids are very efficient. They're good at what they do. They're the reason we chose R10A. There's a reason we're moving 454B and R32. And that is, it has a good bottom line in terms of your electric bill at the end of the month. And it has that nice added environmental story of what's going on with the atmosphere beyond the equipment. So it is that twofold component. And I think it a little bit depends on each homeowner. So it could be up to somebody asking. It could be a great added bonus for somebody that's maybe say, what else am I getting out of this besides reliability, comfort, cost savings, all this, and see, oh, by the way, there's this environmental aspect too.
No, and that's a great point. And that's something that I see way too often when it comes to businesses is and technicians in general is they sell to their own personal
Sure.
knowing and preferences and right, all of that versus meeting the customer where they're at, right? The whole idea of what's in it for me.
Yeah.
And when it comes to sales, that's where you got to start.
Yep.
I love that. Well, as we wrap up here, Nick, what is one question that you wish people would ask you more, but they don't?
This is a very good question. I love this. I think there's a few things, but I'll maybe focus on one specifically. I wish people would ask me, what is the whole story around a new piece of equipment going in? I think sometimes it's easy to get hung up on the individual components of how big is my system supposed to be? How, efficient should my SEER rating be? What type of refrigerant should I be using? But I think there's a bigger story at play with every single system that goes into every home and building in America. And that is, what is the impact across everything, right? When I think about, potentially installing a heat pump, for example, I think it's really easy to get caught up in the minutia of, is it going to be able to provide the adequate amount of cooling and then the amount of heating? And can I make sure that my home is good with that heat pump? But a heat pump doesn't necessarily have to work long, right? It's a system-wide thing. There's going to be backup heat in some colder climates. So Canada, you're probably familiar with this. I'm from Minnesota. It's very real. And these systems that go in are not working in a vacuum. It's a very holistic approach. So maybe there's a way to, get a furnace installed. And this is a good opportunity for the technician to show how they have some expertise here and say, hey, we can get you this new holistic system for your house. Maybe there's opportunities for that homeowner to get insulation installed in there also, even for commercial buildings to upgrade the envelope of that building and then install a system that's designed to meet that whole building needs rather than just focusing on what I think has historically been maybe a more replacement technology focused approach to how we do business here. And it's much bigger than that. So that would be my final question I'd like you to ask more about.
Now, I'm curious for the consumer that's concerned about electricity and relying entirely dependent on that, especially with the, when we see the snowstorms come through a climate that can't handle it, like Dallas, and we get power outages for many, many days. How do you speak to a consumer who has that concern as well?
I mean, that frankly is a very valid concern. I mean, if you are relying on the electric grid to provide your heat, what happens when that electric grid goes out, right? And I think there's options, there's technologies that are around that to make sure that there's alternative fuels. So I think natural gas in a furnace is a good way to, directly address that. But I think there's this added benefit of moving to more efficient technology that helps to make the grid more reliable for everyone, right? When we think about electric heat today, often it's an electric furnace. So in Texas, they're pretty common. You might have somebody's home that's running strictly, and that draw in terms of kilowatts is so extreme. The spikes on that demand in terms of what the utility needs to provide is so high that that's what causes some of these shutdowns. And if you can say, hey, homeowner, by you moving to something that's maybe more electrically efficient, like a heat pump, I think that's kind of the most common example. You're helping to kind of bend down that demand spike. And collectively, as more people move to some of these more efficient electric technologies, the risk associated with some of these winter peak heating issues diminishes. So there's always the direct technology application say, hey, we can provide backup systems. I think some folks use generators in some instances, and sometimes you have to. But as we transition the market as a whole to more efficient technologies, the risk associated with the electric grid specifically can help to be reduced.
Right. Well, and you still see with those generators, and when you do have to kick them on, it's still significantly less of an impact when you're coming to fossil fuels and relying on that as your main go-to source.
Absolutely.
Yeah. No, it makes a ton of sense.
It's a very complicated puzzle that I think we're in. I'm sure you've experienced it too. I'm sure there's probably some level of demand in the summer that Alberta's not used to yet, but we'll figure it out collectively someday.
Absolutely. Absolutely. Well, Nick, I truly appreciate you coming on. Thank you for taking some time. Enjoy the rest of the show. And until next time, cheers.
Yeah. Happy AHR. And thank you, Bobby. Cheers.
Thanks so much for tuning in. Definitely want to hear what you thought of this episode. Leave a comment down below, let us know. And if you really want to show some support back to us, we could really appreciate if you would hit that subscribe button as well. And if you did want to get notified when we come up with a new episode, hit the bell icon over there. Thanks so much for tuning in, and we'll catch you next week.